Welcome to another API Spotlight. The goal of this video is to cover the Java Date and Time API first introduced in Java 8. This standard has become one of the best date and time APIs out there, and many new implementations such as the newly proposed JavaScript Date and Time API are based off of it. The API was designed with immutability of types in mind. Unlike other date and time libraries, once you create a type, the only way to modify it is by transforming it into a new object. This leads to thread safety of types and avoids having partially initialized types. This caused problems with Java's previous calendar API. Further, you'll see that method names have a very predictable pattern. This aids in finding the correct method without needing to resort to searching Stack Overflow or Javadoc references. There are 9 main prefixes that methods are grouped into. Of and from are your basic creation methods and create new instances of a class from primitive values or other classes provided by the library. Parse can be used to transform the string representations into new instances of the types. These typically use the ISO 8601 standard representation for the respective type. Get and is are the accessor methods and can be used to retrieve and query about the state of the object. Finally, with, at, plus, and minus are the modification methods that can be used to transform a type into a new type. Plus, minus, and with will all return the value of the same type, whereas at transforms it to a new type. The first type we'll cover is the LocalDateTime type. This type is what most people think first about when they want to model time in their programs. To construct an instance, you can use the of method and enter in the year, month, day, hour, minute, and second of the timestamp that you want to use. This type has no concept of time zone, and as such does not represent a specific point in time. You can think of it as the local wall clock time. Depending on where you are, this time will mean something different, but the concept is still the same and has certain properties that can be queried from the type. This type can further be broken up into 2 constituent types, the LocalDate and LocalTime types. As you could maybe guess, the LocalDate type represents a date independent of any time zone information and without a time. This is possibly one of the more useful types from the library. You can use it to represent holidays or other important dates in your application's domain. The LocalTime type also has a predictable meaning. This represents wall clock time and is not associated with any date. The timestamp will always be based on 24-hour time and does not handle time zones or daylight savings time. All of the aforementioned types don't know anything about time zone and are therefore also called time zone naive types. If you need to worry about time zone, the API provides a ZonedDateTime type that merges the LocalDateTime object with the zone ID. The zone ID represents the time zone that you need to represent time in. It holds the information for what offset from UTC you are currently in and when that offset switches for daylight savings time. This merging of LocalDateTime and zone ID allows comparison of different times against each other without needing to worry about the time zone differences. Additionally, the API provides a way to model a specific point in time without needing time zone information using the instant type. This type can be constructed directly using the millisecond since epoch standard, or a zone date time can provide the instant that it is at. With these date and time types, it is also helpful to represent the delta between those types. Here, Java provides 2 classes to represent this depending on your use case, the duration and period classes. A simple way to think of the difference between these is to associate duration with time and period with dates. Here, durations represent the difference between 2 dates with respect to time. This can be up to nanosecond precision and up to a day granularity. Duration doesn't deal with lengths of time greater than this, as it will always represent the same amount of time regardless of when the duration starts. Period, on the other hand, represents a length of time only when rooted at one end. It can store lengths with day precision and up to a year granularity. An important thing to note is that a period will change length depending on its start time. For instance, a period of 1 month depends on which month we are in. February will have only 28 days, whereas March will have 31. The API also has some other niche classes that handle some of the edge cases that you may run into. Here you can see a basic list of some of the more common APIs. Month and day of week are enums representing those types. Year month combines a year with a month and allows querying for how long a month is in days. Finally, month day combines a month with a day and can be used to store dates that repeat every year, such as birthdays. For further information about Java's Date and Time API, there are links provided down below in the description. If you found the information helpful and want to see more videos in the future, please comment down below on which APIs you would like covered in future videos. Thank you.